Taking a look at 3.6 part 2, right? Really, you can actually do without these theorems because you already know the ideas behind them. But we are going to go over them and go through them here and talk about how you know they're actually true. So what the first one actually says today is if my transversal, which is my line T here, if my transversal is perpendicular to one of the parallel lines, it will have to be perpendicular to the other. And the reason that is, if my lines are parallel and my top angle here is 90 degrees, corresponding angles tell me that angle 1 should also be 90 degrees then. So if my transversal is perpendicular to H, if T is perpendicular to H, then T is also going to have to be perpendicular to K. And that's what our first theorem here says. If a transversal is perpendicular to one of the two parallel lines, it must be perpendicular to the other. And the reason that is these corresponding angles have to be equal. If you need more time, please pause the video. Right, but we're going to move on here. Taking a look at my next idea. It says that if two lines are perpendicular to the same line, notice how M and N are both perpendicular to P. Well, that would mean that angle 1 was 90 degrees and angle 2 was 90 degrees. So your corresponding angles would be equal. If your corresponding angles are equal, your lines are parallel. And that is exactly what your next theorem, theorem 3.12, says. If two lines are perpendicular to the same line, if M and N are both perpendicular to P, then M and N will have to be parallel. Once again, if you need more time, please pause the video. Taking a look at example 2. It says determine which lines, if any, must be parallel in the diagram and explain your reasoning. Now, we are going to do only based on the markings and what we learned today. We're not going to add in any other markings. So we can say that R is parallel to S, and as for our reason, they were both perpendicular to line X. Likewise, we can say X is parallel to Y. As for our reason, they were both perpendicular to line R. Likewise, then, we could say X was parallel to Z. As for our Y, they were both perpendicular to line S. Right? Yes, I understand you can put other markings in that in based on things that we know. But those, I just wanted to highlight what that theorem actually meant and what it told us about our lines. All right, bring us to our last idea here. It talks about the distance from a point to a line. If I wanted to measure the distance from me to a wall, right, I'm not going to measure the distance from me to one of the corners. I'm going to walk straight to that wall. So when we talk about the distance between a point and a line, we are going to be talking about the perpendicular distance. So I need to meet that line at a right angle. It is the length of the perpendicular segment from a point to the line. So if I have a point, and then here's my line, I'm not going to go at an angle and measure the distance here. All right, I'm not going to go at an angle and measure the distance here. We don't do that. We measure the distance from the point, and we want to be perpendicular to that line. This is the distance from the point to the line. Which brings us to our last example here in example 3. It says, what is the distance from point A to line D? Now, in order to find that distance, We need to find that perpendicular distance. So we need to work with our slopes, because that's how we tell if things are perpendicular. So the very first thing to do is find the slope of line D. So find 2 points that you can use on line D. Here's the point 1, 0, and I'll use this point here of 2, 2. So we have 2 minus 0 over 2 minus 1. So we get a slope of 2 over 1, or just 2. Your perpendicular slope, then, as we have talked about, must be the opposite reciprocal. So it must be a negative 1/2. Point A was at negative 3, 2. Now, to make my line, I'm going to use my slope, and I'm going to go down 1 and right 2. So there's my next point. Down 1 and right 2. So here's my next point. There is the line that we are finding the length of. It is the length of this segment right here. So I want the length from negative 3, 2 to 1, 0. As a reminder, we use that distance formula. The square root of, I do negative 3 minus 1 squared plus 2 minus 0 squared. Negative 3 minus 1 is negative 4. 2 minus 0 is 2. Negative 4 squared is 16. 2 squared is 4. We add them together and we get the square root of 20. Now, they do not specify whether it needs to be in radical form or if it needs to be in decimal form. So if you're putting it as a decimal, we round to 2 decimal places. We can do 4.47. If you tried to reduce it as a radical, you will get 2 square roots of 5 as your other answer. Both are acceptable here. Right? As for your homework then, I'm sorry, there was one last independent practice problem if you were looking at your note packet. I'm not worried about it. We are going to skip that example. Instead, we are going to get started on your homework here. Pages 194 to 195, numbers 2 to 17.